All right. Okay, so this is going to be a tutorial video on how we can find a confidence interval to estimate a mean, which is different than estimating a proportion, slightly different, same structure, but let's just jump right into it. Your college math professor wants to construct a 90% confidence interval to estimate the true mean score on his last exam. He takes an SRS, a simple random sample, of 50 exams from his students and finds that the sample exam or the sample mean score on the exam is 55% and the sample standard deviation is 6%. The first thing you want to make sure of is that you are in fact doing a mean and not a proportion, and even though there are percentages here, he's looking for the mean score, so don't let the percentages confuse you. We're still looking for means, so these are not proportions, these are means. So the first step is we want to state what the parameter is that we're estimating. So again, in this problem, we just read through it. We find what he's looking for. He wants to estimate the true mean score on his last exam. So the true mean score on the last exam, or on the professor's last exam. So that is what we're looking for. We'll use that later when we're interpreting the interval itself, but for now, that's all we need to do for the state part. So now we need to identify some components that we can get immediately from here. So we first need to identify the sample mean, which I use X bar as our symbol for that. Luckily for these problems, and for mean problems in general, you probably will be given this, unless it asks you to calculate it yourself, but they won't do that with large sample sizes like that. So the sample mean is 55%, so we'll just keep it in percent. We'll just say 55 is our, if you want to put percent, that's fine too. It's not going to change anything. So our sample mean is 55. Next we need to find our sample size. So our sample size is just how many people he looked at. He took a sample, or how many things he looked at. He looked at 50 exams, so our sample size is 50. Our sample SD standing for standard deviation, so our sample standard deviation, that is also given to us, it's 6. So our sample standard deviation is denoted with this S of X. It is given to us, so it's just 6. And then finally C is your confidence level. You should know that. For the exam, that C represents confidence level, but we read the problem, he wants a 90% confidence level, so you C equals 0.9 or 90, it doesn't matter which way you want to do it. So we have completed the identify stage, and now we're going to jump into the planning stage. And in the planning stage, we need to make sure that our two conditions, our 10% and our normal conditions, are met so that we can properly create a confidence interval. So the first one is that our sample needs to be less than 10% of our population size. In college math classes, there can be many students taking an exam. We'll say it's at a big university. I guess I should have written that in there. Let's say that there's 1,000 kids that are taking this math class. So in that case, we need to make sure that the 50 exams is less than or equal to 10% of our population size. So our population, remember, we're going to say is 1,000. So this big capital N is population size, so we'll say that 50 is less than or equal to 1,000 over 10. We need to make sure that this is true. If we divide this out, 1,000 over 10 is just going to be 100. So 50 is less than or equal to 100, which is certainly true. 50 is less than or equal to 100. So our 10% condition is met. Check. Boom. Often for this, to estimate the population size, you can either ask me or just use your inference on that this might be a really large number depending on the population that we're looking at. Finally, our normal condition. To meet this condition, our population either has to be normal, or it has to be told that it's normal, or it has to have a sample size of larger than 30. So it doesn't tell us in here whether or not the distribution is normal, so we can't assume that. So we have to make sure that n is greater than or equal to 30. as our threshold. Our n is 50. We know, again, I hope you know this, that 50 is greater than or equal to 30, specifically greater than. So this is met, and our normal condition is met, which means that our two conditions are both met. They both have to be met, and we're good with the planning stage. So we'll be able to make a proper interval for the situation. On to our fourth stage, we need to calculate the things that we need, which are, in this case, the critical value, the standard error, and then the interval itself. So we remember that the general form of a confidence interval is our point estimate, plus or minus our critical value times our standard error. Okay, so our point estimate is going to be our sample mean for this one. For if we're trying to estimate a proportion, our point estimate would be a sample proportion. In this case, we're trying to estimate a mean, so we're going to use a sample mean as our point estimate. So we have x bar plus or minus our critical value. For means, since we don't know the true mean or the true standard deviation, we use t star. This is different than the sample proportions. In sample proportions, we use z star because we only don't know the sample proportion. But we're going to use t star for means, so you'll have to separate that. Z star is for proportion, t star for means, and then times our standard error. Our standard error formula is like the formula from last chapter. So let's start off by calculating that first, since I'm talking about it. So our standard error formula for a sample mean is pretty simple. It's just our sample standard deviation, which we already found, over the square root of our sample size. So if we plug those numbers in, we have s of x is 6. And then we're doing take the square root of n. N is 50, so we're going to take the square root of 50. That should be a little bit over 7, just because square root of 49 is 7. So we know it's going to be a little bit over, but if we calculate this all the way through, we will get that the sample, or the standard error, is going to be 6 divided by the square root of 50, which is 0.84, we'll round 9. So 0.849 is our standard error. Next, we need to find our t star. Our t star requires us to find our confidence level and then the degrees of freedom for this problem. Now remember, we don't have the degrees of freedom for the z distribution, but for t star, when we're looking for t star, we need to calculate our degrees of freedom. So our degrees of freedom in your notes is n minus 1. So our n is 50, so our degrees of freedom is 49. So to calculate t star, we need our degrees of freedom, which we've now identified as 49, and our c, our confidence level, which is 90%, or 0.9. So on your table, it's a little bit easier than calculating z-score or z-stars. You would look on your table and find the intersection. You would find the confidence level column, and then you'd find the row that's closest to 49. So in this case, on your table, it's probably going to be 50, and you'd find the intersection of the row and column that correspond to degrees of freedom being approximately 50 and a confidence level of 0.9. If you can do it on your calculator, like I am about to do, that is okay too, but I would stick to your table unless you are sure of what you're doing. So I will quick find that t star, and it's going to be approximately 1.677. So we use this information plus the c to find that our t star is approximately 1.677. You might come up with a slightly different answer if you're using the table, because I used the calculator. It's a little bit more exact, but it's going to be around there. As long as it's around there, that's okay. So now we have our t star, our sample mean, and our standard error calculated, so we can create our interval. We're just going to use this formula and plug everything in. So we get that 55 plus or minus our t star, which is 1.677, times our standard error is 0.849. And so this is going to be our interval. We're going to find the lower bound first by subtracting the right side. So our lower bound is going to be 55 minus this on the right side, So 55 minus 1.677 times 0.849. We get that's 53.576. I guess we probably didn't need to round that much. That's okay. And then our upper bound we find by adding. So our upper bound is going to be 55 plus that number, 1.677 times 0.849. And we get that the upper bound is the upper bound is 56.424 if we round. Okay, so now we've calculated our interval. We know what the range of plausible scores is. So the last thing we have to do is interpret the interval, which is part of the conclude stage. So this is the ending act. So we use the structure of the script that you guys have been using this whole chapter on your notes, and we just stick to that. So we're going to say that we, or I, depending on your point of view on the world, we are 90% confident at the interval from, and now we're going to use our lower bound and our upper bound, so that the interval from 53.576 to, and then our upper bound is going to be 56.424, that interval captures the true mean score. So this is the parameter we were trying to estimate, the true mean score on the last exam. Okay, so if you watch the proportion video, it's very much the same steps and process, and then you will be done. So that's it.